Okay, I'm going to work on problem 11 from chapter 8. And what this has is it contains power plant output or power output over a period of 10 weeks. So this is be like the average for that day, would represent each entry in the data file. So seven columns, one representing each day, and 10 rows, one representing each week. And we'll use the symbolic constants n rows and n columns to represent the number of rows and columns stored for the period, okay? So what we need to do is write a program that computes and prints the average power output over this period, okay? And then we'll print the number of days with the greater than average output power, okay? So first thing I'm going to do is I'll start Visual Studio. And create a new project. Next. Then I'm going to say some more. Chapter 8. Problem 11. Okay, and I'll put it on the desktop. Create. Okay, so here we are. I'm just going to delete this. And delete this. Okay. So first thing we're going to do is we need to include fstream, because we're using a file. And then I'm going to create those two constants as defined in the problem. So I'm going to say row size equal to 10. And, oh, sorry, integer, of course. Integer, row size equal to 10. Then column size, right? Because we have 7 rows, 7 columns. We have 7 columns equal to 7, one representing each day of the week. All right. Then I'm going to do using namespace, as usual, std. Okay, so that's good for now. Then what I'm going to do is I'll go in here and I'll just do return 0, which essentially means that it completed successfully. System, we could do a system pause here. One way to stop it from going through and closing the window when we're developing it, when we're writing the code. Okay, so first thing here is I'm going to create a variable for each entry in the file. So it's basically the average daily power. Okay. Then I'm going to create a input file stream object. This is what I'm going to use to communicate or connect my program to my file. And then I'm going to create another variable called file name. So this contains the file name I'm going to use. All right. So the first thing you need to do is prompt the user to enter the file name. Now you could hard code it in, but this is a little more flexible if we write it so that we prompt the user for the file name. That way the file name could change. So we'll say enter the file name. All right. Semicolon. Then we'll do cin file name. Okay. Then we'll say if file input dot fail, then we want to display a message, error message, right? So we'll say cout error opening file end line. And then I'll do a system pause here because I want it to stop. Otherwise, it'll close the command line window. Right, and then I'm going to do return -1. And of course, you could always do Control F5 if you wanted to execute it so it will stop. Oh, you know what? Didn't spell this right. So let me do this. Daily power. All right. So let's see if it works. It will actually go and open the file. It'll give me an error message. All right. So I run it. And I'll say power 1.dat. Okay. So it actually read it correctly. Well, it didn't give me an error message, of course, because I did forget one thing here. I got to try to open it. So file, input, dot, because by default the fail flag is false. So I need to try to open it. And so this would be file name dot cstr, like that. That'll read in that file name. Okay. So let me try it again. And our expectation at this point should fail because I didn't move the file to the right place yet. But I'll do it power 1.dat. And there it is. Okay, so it fails, right? It fails because I didn't take the file and move it to the right place yet, right? Okay. And this file, of course, is on the website underneath the files link on the website. Okay, so file1.dat. Oh, okay. So I didn't pull it back yet. I need to go get it, right? So I need to go to the website. So do that. So you need to log in, of course, to our course website. Okay, so once you log into the website, you'll see over here on the left-hand side, data files. Click that. Power1.dat. That's what I want. Click it. And it says data file. Okay. So you may or may not have to do this. I'm just going to do power1 like this. And I'm going to save it in the proper location here. So I'm going to go to my desktop. I've got a lot of projects here. But here it is right here. Chapter 8. Problem 11. And then this is, if you looked at it, if you want to see like all files, you'll see this is where my CPP file is. But I'm just going to say data file, DAT, and I'm going to save it here, okay? So mine, actually, I save it in this subdirectory. That's where my CPP file is. It's in this subdirectory, and I just did this to see all files, just to look and see, yeah, it's in this directory. So I'll put back the data, and I'll just do save, okay? And now it gets saved to that location. All right, so I'm going back to my project in Visual Studio. All right, now I'm going to run it again. So I'll stop, run it, enter file name, power1.dat. Okay, and now it's good. Now it opened it properly, so there's no error message. All right, so the next thing we want to do is, what we could do is we can create a function, right, that will calculate the average, and we can pass in our array, right, into that function. And first thing we need to do, though, we can actually create a function to read all the values into our array, or we could just go from right from the main function and read all the data elements in. And that's the way I'll do it. I'll read them all in from here. Okay. So first thing we're going to do is we're going to do a for integer I equal to 0, I less than the number of rows. So rows, oh, sorry, column, sorry, not column, row size, and then I plus plus. Okay. Well, we need to do both rows and columns, so I need to set up a nested array. So I'll say j equal to 0, or a nested for loop. J less than column size j plus plus. Okay. So I'm going to go through and read the elements from my file and store them into my array. All right. So the way you need to do that is do this. So you do file input. Okay. Double arrows. Now I have to specify the array I want to store it in. Okay. Well, I also need to create an array. So let me do that. I'll just say power array. And the size, of course, is going to be how many rows? It's going to be row size, and then column size. So I'm using those constants that I already have from above here. All right? So there's my power array. So I'm going to read it into the power array. POWR array. And then there's going to be I, J. Okay? So that will read it into the array. All right. Now, of course, if you wanted to, do the same thing again, if we just wanted to copy it. So if you wanted to do this, so if I just did this, control copy, and this is read file elements into an array, 2D array, of course, right? 2D, two-dimensional array. And I'll do this as display contents of the array. So this is just checking to see that it actually got read in properly. So we'll do power array. We'll do a cout. So I'll do a cout. So I'm just going to write it out to the output. That way we can see it. And there's one other thing I'm going to do here. I'm going to do this. So this reads all the columns. So every time I get done reading a column, what I want to do, yes, that's right. I want to do a cout end line. So I get a new end line, right? End line. Okay. So this is just displaying the contents of this. So let's do it, run it, and see that it works up to this point. So we want to make sure, so this reads them all in, and then this one is just temporarily, I'm just using this to display all the contents. And let's see if it does that properly. Okay, file name, power1.dat. Okay, so there they are. The only thing you notice here, of course, they're all together. So let me do one more thing here. I'll do a tab here. So this is one way I can do a tab. So let's run it again. File name, power1.dat. Okay, so there are all the elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and the 7. So 10 rows, 7 columns, 10 by 7. Okay, so that looks good. All right, the next thing we want to do, we'll go in and do a couple things. One thing is we can calculate the average for this, like the daily average. So let's create a function to do that. So I'll go up here and let's see, what do I want to do? I'll do it right up in here. So I have two. So I'll do a double data type, and I'm just going to call it average. Okay, and I need to pass in an array. I need to pass in the array. I don't need to pass in like the row size and column size because they're already constants here. So if I can use the constants that I created. All right. So here I'm going to pass in the array, and it's a double, and like this I specify by square brackets, define it as a double data type, and then this has my column size. I need to define that initially. Okay, this is used when you have two-dimensional arrays. You have to specify the column size, otherwise when it goes out and allocates like an array, when it does it here, it just creates like, 10 rows times 7 columns, 70 elements in a row. This helps in terms of accessing it. So it says, oh, okay, so you're going to have 7 columns. So however big this array is, whatever, there's 7 columns in it. Okay. There is one more thing. Oh yeah, we don't need to do that. We don't need to pass anything in because we can just use these constants. These constants can be accessed anywhere in my program. Okay. All right. So now I have, oh, didn't forget my semicolon. So now here's the prototype, right? Here's the function prototype for average. So function prototype for average. Okay. The next function I'll need is the second part. I'll save that for later after we go through and calculate the average. Okay. So now I'm going to go down and create the function that actually calculates the average. So it's going to be double. This is the function definition for average. And I'm just passing in that 2D array. So it's going to be what I call power array. I'll just call it, how about just power EGR? Really doesn't matter. As long as it has some significance, the name should mean something. And then this is column size. Okay. So inside the function, what do we want to do? Well, we essentially want to do the same thing as this, right? So I'm going to just do this. I'll tell you what, I'll do this. I'll do it like this. I'll copy this because I want to go through each element. So I'm going to do a copy. This goes through every single element. The only thing I need to do is I need to change the name here. Something's wrong. What is wrong? Okay, so average, double. Okay, function definition here. Oh, double, like that. Okay, there we go. Okay, so I thought there was an error here, but this is, so here's my function definition so far, which I need to fix, but here is my function prototype, okay? All right. Okay, so this actually goes through each element. When I do it nested loop like this, it will go through each element in the array, okay? Now what I need to do is I need to create a variable here. And I'll just say double sum. So I have a variable called sum, right? And of course I'm going to set this equal to 0. Okay. Now what I want to do is I just want to keep a running total of this sum. So sum is equal to sum plus whatever I read. So what this will do is, and I don't need this one, this will actually just total all of the elements in my array. The last thing I want to do, return sum divided by row size times column size. Okay. So what you could see here, the way I wrote it, is that so this gives me the average. This returns the average, which is what? The summation of all the elements divided by the number of elements, because this row size times column size is 70 elements. So that gives me the number of elements in that array. Okay. So this returns the average, right? Sum divided by that. Okay. So then we can come down here and we can actually make a function call. So we'll say cout, and I'll say average daily power, average daily power output, okay, equals, and then I'll do my function call right here. So I'll say average, and then I need to pass in the name, which is called power array. Power a, okay. Now I'm not going to go through all the numbers. You could actually put it into, oops, uppercase A. You could actually put it like in a spreadsheet and figure out what the average should be from there. You could do some calculations. But what I'll do is I'll assume it's correct, and the way we'll verify that it's correct when we go through and calculate the number of elements that are above the average, or number of days that are above the average. We'll just manually count those and see if it matches. And I think if that comes out correct, we can be pretty confident that it worked correctly. Okay, so let's run this. And we can also check for, is it a reasonable number, you know. So run it. So it's power 1.dat. And it says the average daily power is, I'll put a end line in there, but it's 237.271. And it's in megawatts, so let me do that. Let me just put this in. Megawatts. Okay. So that should work. Oh, well, oh, right. And then end line. Okay, so that's the average. All right. And the second part of this, we need to print the number of days with the greater than average power output. Okay, so we'll do that. All right, one more thing we'll do here. So back to my project here. I'm going to go over here, source files. I'm going to say right click here, add existing item, and I'm going to select power1.dat. Select the actual file, and oh, what happened here? Let me run it again. Oh, it just gave me a warning. Okay, so I pulled in power1.dat. Okay, so there's the file. There's the element. So 237, I think, when we ran it. Let me run it again. File name, power1.dat. Okay, so it's 237.271. So let's see if we can just get a quick count of how many elements are above that. Okay, so I'll close this. Open up power1.dat. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, I think it was 37, so 33, 32, sorry. So it should be 32. It looks like 32 times it was over the average. So let's see when we create the other function that we see if it comes out to be more than that. Okay. So let's create another function. This one will be an integer data type because it's just a count. So integer, we'll call this one over average. And we're going to pass in double. Same thing. Column size like that. Function prototype. Right, and it's the over average one. All right, so now what we'll do is we'll go down here and we've got another function. It's actually similar to this, so I'm just going to do this. I'm just going to copy it. Control copy. Just push that one down. Control V. And I'm going to call this one over average. Okay. All right. So over average, integer. Oh, integer. We need to change this to integer. Okay. So just like before, we need to read in all of the values for this function. There we go. Still had that squiggly line, red squiggly line. That was an error, but now it's not an error. So we need to have a count, though, this time. So let's call this integer, C-O-U-N-T, count. And that's going to be equal to 0 to start. All right. Oh, we also need to do one more thing here. We need to pass in the average. So double, I'll just say AVG, right? So when we actually make a function call, we need to pass in the average value, right? Because that's what we're going to use for comparison. So I'll just do double up here. So it's a little bit different. Okay. Okay, so inside of here, we don't have sum anymore. Okay, so this is going to be gone. All right, so what we need to do is we need to read each element in, and we need to compare it. So we need to do if power array element is greater than AVG, then we do count plus plus, okay? And then we just return that. We just need to return the count. So we're just keeping track of that. Returns number of elements greater than the average. All right? So there's my other function. Here's my function definition for over average. What did I say? 32, I think. 32 elements I counted from that. So I do save all. And now what we want to do is we'll just do this. I'll just do cout. Cout days over average equals, and then here's my function call over average. Okay. Now there's one more thing we need to do. We'll have to create one more variable here and then use that variable rate when we run this because I need it here. Okay. Over average power array comma what am I going to call this? Daily AVG. Okay. So I'll say daily AVG, or, oh, I'm sorry, it's not a daily AVG. It's, how about I call it overall AVG. And then it's megawatts also, right? Oh, no, count, sorry. Days over average. We don't need anything else. All I need is end line here. Okay. But, of course, I didn't create this variable yet, the overall average, and I actually need to execute that function and save the results into this variable. So overall average equals, I'm just going to take this and move it over there. So I have like a result. So then I'm going to call this overall average. Okay. All right. So I got to go up here and create another variable called overall average. Overall AVG. All right. So now we're good, and we need a semicolon. Okay. So let's see overall average. Let me see. I did it AVG. Okay. So now I calculate this. I get the return from this function average, and then Now I store this in a variable overall average, and then I use it here to display it, and I also use it to make as part of one of the arguments in my function call over average. Okay. All right. So overall average is the actual average power. Okay. I'll tell you what. I'll change it power average so you don't get doesn't get confused with over average, right? So I'm going to call this one overall power average. All right, so I did that right here. I'll put this out on the website. Overall power average. I'll save this code on the website. Okay, so let's run it. Power1.dat. And it says 33 days. Okay, so maybe I missed one. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. Okay. Okay, we're 33 this time. So 33 matches. Okay, what we expected. All right. So that meets the requirement of that program. And that's it.